about the heart, the structure of the heart, and these loops for the blood flow. So, as we begin to look at this information, we're going to find, first of all, please do not leave my class and say anything other than 2 atria, 2 ventricles. All right? I have actually been told that sometimes they get to the programs of choice and do not know that there are 2 atria and 2 ventricles. Atria on top, ventricles on the bottom. All right? Now, the circuits that we have our systemic and pulmonary circuit. When he mentioned the arteries and the veins, and you know, like if you look, you kind of look down, anything that we consider a vein, it looks blue to us, right? However, that's not the color of the blood. He tried to point that out. When blood is returning to the heart through the veins, remember, oxygen has been removed because it's been dropped off at the tissues of the body that need it. And so when we get back to the heart, we've got to go through the pulmonary circuit. The pulmonary circuit, when you look at the structure of the heart, all right. Heart. Look to the posterior side. All right? When we hear the term arteries, veins, arteries take blood away from the heart. Veins return it. Therefore, we tend to think arteries with the red, veins with the blue. For the pulmonary circuit, think of these colors switched, flipped. All right? Because if it's going to the pulmonary circuit, pulmonary is telling us where? The lungs. What does it need to do in the lungs? It needs to pick up the oxygen. So, when the blood returns to the heart, goes to the pulmonary circuit, we're not going to see it being red. Okay? It's going to be blue. It's going to go to the lungs. It's going to pick up the oxygen, and it's going to return to the heart by the pulmonary veins. Now, veins, we tend to think of having blue. Once again, flip it, because it's now been oxygenated we have the red, and it's going to return to the heart by the veins, but this time the veins are red. So this blue and red is flipped for the pulmonary circuit. Does that make sense? Now, once we get back to the heart, okay, it's going to leave by way of the aorta and then travel into all the rest of the body. And that is our systemic circuit, because that's going to go to the systems of the body. Okay? Does that make sense? So, this structure, it's very unique. One of the things that he mentioned, he talked about the pericardium, the sac that the heart sits in, and then we had the parietal and the visceral. Parietal simply meaning to the outer portion. Visceral means that sac, the shape of the heart, it's going to actually be following every contour of the heart for it to be the visceral pericardium. All right? The parietal is to the outer portion, okay? And the pericardium being this sac that the heart is sitting in the mediastinum, okay, in our chest. Now, we can have inflammation of these membranes. It's called pericarditis. It's rather common, especially, you know, the older you get. And you actually, from what I can understand, it's actually very painful, and you're actually feeling every beat of your heart when you have pericarditis. And from what I can understand, very painful. Now, in the heart wall, if we begin to look at the heart wall, okay, epicardium, endocardium, now, myocardium. When we begin to look at this structure, I want you to look at this. Now, your two atria, two ventricles. Okay? When he was talking about the structure, he kind of pointed out that the atria, the heart wall, is not very thick. Okay? If you look at the atria, this heart wall, relatively thin. Now, note the ventricles. Epi to the outside, myo to the middle, okay? Endo to the inside. What type of tissue, what type of muscle tissue makes up the heart? Huh? The cardiac muscle. Looking at our hearts, that's this thick portion running along the ventricles and in the septum. Okay? That is the working portion of the heart. Wait a minute. My atria. What do you notice about those cells, that thickness, that tissue for the atria? There's not a lot there. Why? Because they are under low pressure. When we talk about the atria, the blood that is coming into the atria, very low pressure. It's basically just filling up, all right? And it only has a short area that it actually has to deal with going to. Now, look at those ventricles. Do you notice anything about those ventricles? They're what? They've got a lot of cardiac muscle. Which side has more? You sure about that? The left. If you're looking at the situation of the heart, okay, this would be how the heart would be situated in the chest. Right, left, okay? Note that the left is very heavy in the myocardium, but the right is not. Where does the right ventricle have to pump blood to? It only needs to go to the lungs. We do not need that blood in the right ventricle under a high pumping pressure. It does not have far to go. But my left ventricle that has a very thick cardiac cellular makeup, okay, where does that have to go? To the rest of the body. So we need the pressure higher in that left ventricle. Now, we're going to find out that there's a close connection between the respiratory system, the cardiac system. Anything that is going to affect the respiratory system is going to affect the heart. So, lung diseases are going to actually affect the circulation of the blood in our bodies. We have something called cor pulmonale. In these chronic lung diseases, like emphysema, bronchitis, black lung disease, okay? When we have something that's a chronic lung disease, that is going to actually cause the right side of the right heart, the ventricles, okay, to fail. And we're going to end up with stuff affecting, now we're going to affect the circulation of the blood. We've got the lung disease. What are we truly affecting here? What are we truly affecting? How are we affecting the systems of the body? If I've got a lung disease, now I've got something that's not making my heart pump correctly. The oxygen to my tissues. Now, not only are the lung disease an issue, the heart problem an issue, what's it doing to the rest of the systems of my body? Killing the tissues. So, guess you could say, system-wide.
So that's what like
Like
asthma?
Right. It's when it becomes chronic. However, when it's acute, you can have issues, but hopefully the goal is that the tissues recover. But when it's chronic, there's always a lack of the oxygen going everywhere, tissues are going to start dying. Some of them can't recover. So this is our structure that we're looking at. We've got the sac that the heart is going to sit in, the epi, the myo, the endo. Now, One of the things that's really important about this structure, it helps to anchor the heart in place. And that means we're not feeling it slip and slide all over the chest. So these tissues, these sacs, they are helping to anchor this very precious organ. When we begin to look at the structure, like I said, please do not leave my class and say there is anything other than 2 atria and 2 ventricles. And trust me, I ask, okay? I ask the people in the programs, all right? Now, these are our chambers. We've got the right, we've got the left, all right? Right atria, right ventricle, left atria, left ventricle. And just think of AT, atria on the top, ventricles on the bottom, okay? So AV, just look at it that way. The atria receive the blood, ventricles push the blood out. One of the things that's really important is the pressures that are present. We need to make sure that we try to keep those pressures at a norm. The body's going to want to do that, right? The heart's going to want to do that. Now, when we begin to look at those 4 chambers, where we've got the atria, we've got the ventricles, we're going to find that we have an atrioventricular sulcus. Do you happen to remember what a sulcus was? A groove, okay? And what would you think if you hear atrioventricular? A separation between an atria and a ventricle. Now, how about interventricular sulcus? Ventricle to ventricle, in between those 2 ventricles. When we begin to look at the outer surface of the heart, where we're going to see very prominent grooves, okay? The very prominent sulci. Look at your heart. All right? This structure has very prominent sulci, grooves that are present. That contains the coronary arteries. What does that mean? Huh? What? You're speaking really loud. Now, the heart is a pump, and we look at it as the pump that is receiving the blood and then sending the blood back out.